Hey, I didn't think you'd be back. After that last video, we had some really tough, lengthy problems in section 1, part A, especially toward the end. They took some time, but again, we didn't get use of a calculator, so the algebra was easy. Let's start section 1, part B. Okay, there's 17 questions in this section, multiple choice still, and we get to use the graphing calculator. Dude, noise. Yeah, that's noise with an O. I didn't misspell nice, okay? Well, I mean, I guess I did, but it was intentional. Noise. But these 17 questions will be broken up into 2 videos. I'm going to do 9 questions on today's video, problems 76 through 84. And then I'm going to do 8 questions on the video after that, which will be problems 85 through 92. All right? We get a calculator, so even if the algebra seems very difficult, we get the graphing calculator. All right. Like this video now just because of the way I spelled noise. Well, you know, or you can like it later. That helps me. But follow me. Because if you follow me, that's the only way you're going to get notifications of when I put up the videos that follow this one. All right, let's begin. 76 reads, and you know how I feel about getting graphs. Woo-hoo-hoo, nice. Or should I say, noise. 76 says, the graph of function f is shown above. Which of the following limits does not exist? Quick little review of limits. Limits have to point to the same y value. It can be a hole, or it can be filled in. Either way. All right? In fact, let me do this because I can. Here. That's what a smartboard does. Okay, now I'm going to go back to here, go to here. Okay. It has to point to the same hole. It can be a hole or it can be filled in. So why did I do that? It can be a hole or it could be filled in. Okay, doesn't matter. But as long as it points to that same y value. Okay? Which of the following does not exist? Does not exist. All right. So the limit as I approach 1 from the left. That little minus sign means from the left. Here's 1. I approach it from the left. Yeah, that exists. It's 0. Okay, that equals 0. The limit as I approach 1 in general from both sides. Well, it does. It points to the same thing, which is a y value of 0. Okay. What about as I approach 3 from the left? Here's 3. The left, I'll do this a different color, comes this way. Okay, that has a y value of 2. All right. What about 3 in general? Oh boy. Here's where the poop happens. Here is where poop gets real. All right. Let's follow 3 from both sides. Okay. And I will see if the highlighter will follow this. Boom. Yellow. As I approach 3 from this way, right there. As I approach 3 from the right side, oh, it goes down forever. Okay, remember, lines, dash lines. This is the line of where x equals 3. As I approach that from the left side, I approach a value of 2. But as I approach it from the right side, it goes to negative infinity, which means it goes down forever. This does not exist. They got to approach the same value from both sides. Simple question. These questions can be simple, but for some reason people overcomplicate them, and I'll explain why in a minute. 77 reads, let f be a function that is continuous over the closed interval from 1 to 3, with f of 1 equaling 10 and f of 3 is 18. So right away, I always tell my students, when you see this, this is a coordinate. When x is 1, y is 10. When x is 3, y is 18. These are both x values. That's the interval. All right? Which of the following must be true? This is what throws people off. Because you start to read these things and you say to yourself, well, this can be true. They're not asking you which of the following could be true. They're saying which must be true, which means no matter how you come up with a scenario, it will always be true. Let me state it another way. There is not a scenario where you can come up with that would make it false. So if you have something that could be true, Well, then it could also be false. That's not what I want. I want something that will always be true no matter what the scenario is. Okay? The first thing I'm going to do is draw a graph. Here's where x is 1. Here's where x is 3. No, here's x is 2. When x is 1, my y is 10. I'll put 10 right here. 110. There's that point. Beautiful. When x is 3, y is 18. Let's go right here. 318. There's my point 318. All right. F of 2. Let's look at A. Let's evaluate A right now. Okay. F of 2, which means when x is 2, what's your y value? It's got to be between 10 and 18. It does not. Let's say it's 5. Maybe I can have a point here. I can have the graph come down here and then come up. Okay, this doesn't have to be true. It could be true, but that doesn't always have to be true. Boom, I just came up with a scenario where it wasn't. Let's get rid of this. Do this in different colors. B. F is increasing on the interval. That means it's always going up. No, I just did one where it could have come down first, then up. It doesn't always have to increase. It can, but not always. I can come up with a scenario where that doesn't work. All right, let's get it. Oh, C. F of x equals 17 has at least one solution. All right, so let's do this in, orange. Here's 17. I have this line. All right. I need to, it has at least one solution. Okay. Do you see this right here? It's continuous, the function. I can draw it without picking up my pen or pencil. There is no way possible, no scenario that if I start here at 110 and I go here to 318, there is no way possible I can connect those two dots without touching this line 17 at least once. I have to, okay, boom, I touch it once. Oh, what if I come down here? I touch it at least once. What if I come through here? I'll do this in green, and I go, Well, I touch it at least once. Okay, why? Because they tell me it's continuous. And that makes C true no matter how I draw that line. There is no way I can connect my 2 points that are given to me in the problem without going through a y value of 17 at least once. You know, I gotta give it up to the people who make these tests. When you get to this section, 1B, and you can use your calculator, the relief you feel. But we haven't used the calculator for the first 2 problems, and it looks like we might not have to even use a calculator for the next problem because we're simply going to set up the math and not do the math, okay? All right, here we go. Let R be the region bounded by the graphs of y equals e to the x, y equals e to the 3rd power, and x equals 0. Okay? Which of the following gives the volume of the solid formed by revolving R about the line y equals -1? All right. All right. So I'm going to draw a picture of this. And if you don't know what this looks like, guess what? You can use the calculator to graph this. You can actually graph this, okay? So I know what this looks like. But if you don't, again, I'm going to say this one more time. Here's y, here's my x. You graph this. You graph y equals x. That's actually going to look something like this. Here's the number 1, where y is 1. I will do this in red. It's going to look something like this. This is y equals e to the x. I'm sorry if I said y equals x. It's y equals e to the x. All right? In blue, I'm going to graph y equals e cubed. E cubed is a constant. There is no variable. Y is a variable, and x is a variable. E is the number 2.718, etc., etc. Okay, we are taking a constant and raising it to a constant, which gives me another constant. Let's say here is e cubed, this horizontal line. That's y equals e cubed. All right. And x equals 0. X equals 0. Okay. Is this right here? Do that in green. X equals 0. So they're going to take this solid and revolve it around the line y equals -1. Okay, so, oh man, we need another color. Let's go, I mean, orange, we'll go to this minty green. Y equals -1. That's where we're revolving around this, okay? That's not a G, that's an arrow being revolved. So, we're going to take the solid, meaning it will look like that, because if I reflect that, it would kind of look like... Oh, man, am I going to run out of space? I drew this way too big, but that's all right. And then the blue part's going to... Okay, and e to the 3, if I reflect it, it will just... something like that. Okay, so I've got this disk, okay? Here, I've got this disk that I'm revolving around y equals -1. Okay, y equals -1. Good. Oh, I love doing volume problems. Anytime I integrate a volume, I'm using circles in this case, I need to integrate the area, but it's the area of the outer. Okay, what do I mean by outer? This is the bigger function right here. Okay, e cubed is a bigger function. It's higher up on the y-axis than e to the x. Okay, so this is the bigger function. I'm going to take this area of this circle, integrate that area, and subtract the area of this circle. Okay, because what I'm highlighting here in green, I want taken out. If yellow was filled in completely, I want that taken out. So let's start. All right. Oh boy, oh boy. Oh, go here, go here, here. Integrate. The area of a circle is pi r squared. Pi r squared. Anytime I want volume, I integrate area. You need to know that. Okay, my pi is going to go on the outside. My r squared. All right. Well, let's see here. My radius. My radius, and here's the kick to the proverbial like pantalones. All right. My radius. If I was going from the x-axis all the way up to here, my radius would just be this. Okay, but I'm not. I'm going from the 1, so I got to add an additional 1. To get from here to here, I need to add another space of 1. Yes, I realize this is -1, but I'm adding, that minus just means directional. It's going down 1. So I'm starting my radius from here. So whatever this is, which is e to the 3, I need to add 1 more to that distance. That's the radius. So it's the radius of the bigger, okay, radius is squared, right? But I got to subtract the radius of the smaller one. We'll do this in blue. If I was going from here to here, kids, that would be, well, you can't see it. That's where I get y equals e to the x, okay? But I've got to add this distance of 1. I'm going down 1. So I'm taking e to the x and adding this distance of 1 to it. That's the radius of the smaller circle. And again, it's the radius squared. All right? And don't forget, you got to put dx next to it. Now, I didn't put anything with the bounds here. Okay? There's only one thing that looks like that. It's right here. My bounds, I start, and we'll do this in orange, from here, where x equals 0. How did I know my upper bound would be 3? Well, they connect right here, so I got to do it to this point. Right here, e to the x equals e to the 3. Guess what? this x needs to be a 3 for these to be the same. X has to equal 3 here. That's my right bound. You could graph that and use the intersect function in your calculator. You absolutely can. But you need to know how to set up volumes. You integrate areas. Choice E. All right, 79. I think we're finally going to get to use the calculator because I'm looking at the answers, and there's some decimals in there. And when I say calculator, I mean I'm finally going to use it to calculate numbers. The other problem, 78, we could have used it to graph that graph if we didn't know what it looks like to draw it. But here we go. The number of people who have entered a museum on a certain day is modeled by the function f of t, where t is measured in hours since the museum opened that day. The number of people who have left the museum since it opened the same day is modeled by g of t. All right, so f of t is in, g of t is out of the museum, okay? If f prime of t equals 380 times 1.02 raised to the t, and g prime of t is 240 plus 240 sine of pi times t minus 4 all over 12, that's a mouthful. At which time t, from the values or the interval from when t is 1 to when t is 11, is the number of people in the museum a maximum? A maximum. Okay, when is it a maximum? All right, so what I'm going to do is I'm going to graph these. Now, this is the rate of people going in, okay? This is the rate of people going out, okay? And for the people, and this is logically to understand, in order for the max number of people to be in, all right, as long as this rate is constantly bigger than this rate, the people inside will keep on getting larger and larger, the quantity of people. Okay, let's say at the start of the day, 20 people are coming in per hour, and only 2 people are leaving per hour. That's a difference of 18, right? So every hour we're getting 18 more people in, 18 more people. All right, well, what if later in the day, the rate of people coming in, okay, let me write this. If in, these are rates, 18 in and out is 2. So per hour, there's 16 more people every hour that's being added in. Okay, so let's say later in the day, well, there's only 12 coming in, but now there's like 5 going out. There's still that difference, 7 more people going in. Okay, and then at some point, maybe there's 9 and 8. Okay, well, there's still 1 more person. These are all positive numbers that are going in per hour. It's increasing. The moment this switches, okay, in fact, let me get ahead. Let's say at some point 5 are coming in and, I don't know, 10 are going out. Now I'm losing 5. It's no longer growing. I'm losing 5 people per day. So I need to keep on going to where these things become the same. Let's call it 10 are in and 10 are out. There is no change anymore. Then the people start leaving the museum. Maybe now there's 8 people. Now there's 10 people leaving per hour. So I'm going to keep on getting more and more and more people until they're the same. After that, we're going to start losing people. At this point right here is when I'll have the max number of people, because I'm increasing and increasing and increasing, boom, until I hit this point. Now it's decreasing, 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 decreasing. I'm going to graph the rate of the people coming in and the rate of people coming out. And you'll notice that the people coming in on the graph, it's always higher. At some point, they're going to be equal. And at that point, that's when we start losing people. So let me graph f of t, all right, which is 380 right, times 1.02 raised to the x. And then I'm going to graph the people going out, okay? And that is, oh, this is a 240 plus 240 sine of alpha y equals enter. Oh, my goodness. That is pi, look at us go, times x minus 4 all over 12. Okay? I like this problem, but I don't. And again, I want it from time 1 to 11. My interval is 1 to 11 right there. Okay? So I will go to my window, and I'll start at 1 and go to 11. All right? Now, I don't know. Let's graph this. We might have to change our y-axis a little bit, but let's see. Because we're starting at 240 on the G. Oh, we are definitely going to have to change our window. Let's see how the thing is spinning right here. I got to keep on waiting. Yeah. Dabba dabba doo, yeah. Yep. Okay, it's done. So let's go second table. Let's go to second table set. Let's go start at 240. I just want to see how high this thing goes. Oh my God. Oh my God. All right, well, let's go to window and let's just go from 0 to 400. We'll go by 100s. Let's see that. Let's just go way up high. Oh, I got to go higher. Look. Oh my goodness. Still spinning here. The spinning wheel. It's like using your internet browser and that thing just spins and you're like, come on. Okay, so at least I see both of them. Okay, I see both of them, but I've got to go up higher. All right, let's double that. Let's go window, and let's go to 800. All right, this is f of t. This is the number of people that are, the rate that people are entering in. It's constantly increasing. This is the rate where people are leaving, the red one. Boop, right there. Okay, so at this point, they're the same, which means since this graph is higher than this graph, I'm constantly getting more people that are entering the building than that are leaving the building. Okay, more. Okay, at this point, more people start leaving than entering. Okay, so at this point is when I have my max number. I really just got to use my intersect function. Now for calculus, this really isn't that good of a problem that's performing calculus, okay, because you're really just doing the intersect function. Hit enter 3 times, closer to this little point. 1, 2, 3. And that happens right here at 7.888. That's the hour. At that time, that's this time right here. That's at time equals 7.888. Because after that, more people will leave, so I'll be losing people. B. That was a lot of explaining, considering we didn't have to do derivatives, we didn't have to do integrals, but I think people expect that math in these tests. So when you get a problem like this, it really needs, I have to explain this problem a lot more to my students than I do others. Okay, but there it is. All right, simple problem number 80. And again, I think 79 was really the only problem where he absolutely needed the calculator. Unless in 78, when you graphed e to the 3 or e to the x, you needed that. All right, but even here, the math is very simple on this one. Let's read what they give us. The derivative of the function f is continuous on the closed interval from 0 to 4. That's nice. So now I know from 0 to 4, okay, it's, which they don't give us 4, and that's fine. It's continuous. No breaks, no holes, no jumps, whatever. So I'm just going to do this. We don't know what either one of these are yet. The values of f and f prime for selected values of x are given in the table above. If the integral from 0 to 4 of f prime of t dt equals 8, then what's f of 4? Kids, if I have the derivative and I want the second derivative, that's one derivative away, okay? If I have the original function, obviously that's one derivative away as well. But if I'm going backward, that's integral. If I'm going from f prime to f, that's also integral. What does that mean? If I integrate the derivative of f, that's going to give me the original equation. And if I have bounds, let's call them a and b, that's going to give me f of a minus f of b. Okay? In your calculus books, you're going to see a theorem that it makes common sense if you understand bounds, what I just wrote here in red. The integration of f of x is capital F, or something like that, or maybe this is capital F and this is lowercase f. Whatever, and you have a to b here. This is going to say from b minus f of a. Did I write that correct? Oh, b should be here, and a should be here. I'm so sorry. Okay, that's it. Okay, so let's take what they gave us and actually take the 2 minutes. It's going to take less than 2 minutes to solve this problem. If I integrate from 0 to 4 f prime of t dt, well, I'm going to get the original function f from the lower bound, or excuse me, from the upper bound minus the lower bound. They want us to figure out what this is. That's our question mark. Minus. What's f of 0? F of 0 is 5. When x is 0, f of 0 is 5. Okay? The million-dollar question is this. The million-dollar question is that. Okay? Well, you don't have to answer anything. Because, look, they tell you that's 8. I mean... All right, well, let's just... What do I have to take 5 away from to get 8? It's 13. Okay, if you want to add 5 to both sides, go right ahead. 13 is my question mark, which is f of 4. That was so simple. If you just understood that the bounds get plugged into the original equation. Again, this is a problem that they put on the section you need a calculator. Shame on them. This must have been some bitter people in 2016 who wrote this. Bitter people. Number 81 reads, if a slope field for a differential equation is shown in the figure above, where y equals f of x, is the particular solution to the differential equation through the point -1, 2. That's important. -1, 2, right here. Okay? And h of x equals 3x times f of x, then what's h prime of -1? All right, well, the first thing I'm going to do is if I need to find the derivative of h, I'm going to take the derivative of what they gave me, and that's the product rule. Okay? So my first number is 3x, or expression, and my second is f of x. So the product rule states it's the first, 3x, times the derivative of the second, f prime of x, okay, plus the second, f of x, times the derivative of the first. Derivative of 3x is 3. They want that at -1, which means I take 3 times -1 times f prime of -1 plus f of -1 times 3. All right? Okay. This is actually going to be quite easy. Okay? And let's start with this. Well, this is -3. What is f prime of -1? Remember, derivative is the same thing as slope. Well, what's the slope at -1? I go right here, and what's the slope of that line? It looks like I go down 1, 2, and over 1. It looks like it's -2. And it is. Down 2, right 1. Down 2, right 1. -2 over 1, which is -2. That's the slope right at this point where x is -1. -2. That gives me 6. Plus, okay, 3 times, what is actually f of -1? Remember, it's a coordinate. When x is -1, what's your y? They gave it to me in the problem. My y is 2. 3 times 2 is also 6. If I add those, I get 12. I can't get over the bitterness that these people who wrote this test in 2016 had in their lives, where the section where you get the calculator, you haven't had to use yet. I don't know, maybe in the next video you'll have to use it, or the next problem. But your answer is 12, which is choice E. 82. Another one where it must be true. Not can be true, but must be true. If f is a continuous function such that f of 2 is 6, or x is 2, y is 6, which of the following statements must be true? All right, well, you know, we're basically just going to do math here, okay? F of 2 is 6. All right, if f of 2 is 6, let's think about this. If I throw a 2 into this x, I'm going to start at the bottom. I'm basically saying, what's f of 2? I square that whole thing, and that should equal 36. F of 2 is 6. 6 squared is 36. It's choice E. You might look at D and say, well, Visca, how does that not work? Okay, I did this without reminding you that the easiest way to solve a limit is to just plug that number in. Okay? What if I plug in here when x is 2? When I want f of 2 squared equals 36. I don't know what f of 4 is. I don't know what f of 4 is. Okay, punk? What you talking about, punk? I don't know what that is. Bam, and none of these will work. It's E. 83. A particle moves along a straight line with a velocity of 5 plus e to the raised to the t divided by 3 for the time where t is greater than or equal to 0. What is the acceleration of the particle at time t? Glory be a calculator problem. If I have velocity, okay, position, velocity, acceleration. One derivative away. I have velocity, I want acceleration, I take the derivative. I take the derivative of velocity at time equals 4. Okay, so I'm going to take the derivative of this, and I'm going to use my calculator. Awesome. Turn this on. Quit that problem. Math number 8 is your derivative. dx, it is 5 plus e raised to the x divided by, not 6, 3. And I want that when my x value is 4. I'm using x instead of t. That's it. Boop. 1.265. Okay, I'm rounding that up. 1.265. Look at that. C. Real easy. All right, last one, 84. A home uses fuel oil at the rate, okay, this is a rate, this is good, of R of t is 10 plus 8 sine of t over 60 gallons per day. It's a rate, so it should be some unit per time, where t is the number of days from the beginning of the heating season. To the nearest gallon, okay, what is the total amount of fuel oil used from 0 to 60? 0 to 60. If I have a rate, and I want to get to the rate of the rate, that's derivative. If I want to get to the original units, okay, actually I should go this way, that's also derivative. If I go back, I integrate. I integrate a rate to get my unit. I'm going to integrate from 0 to 60, because that's what they want, from 0 to 60, my rate. Okay, and let's see what that gives me. Okay, go back here, go back here, go back here. And I'm going to go math, and this time 9 is the integral. From 0 to 60, I'm going to integrate 10 plus 8 sine of, and that's, I'll do the fraction, alpha y equals enter, of x over 60. Please know that I need to close this parenthesis as well. I have two opening parentheses. I need two closed parentheses. dx. 820.65. 820.65. This is the rate in gallons per day. And when I integrate it, I get my gallons. So to the nearest gallon, 820.65, boop. The nearest gallon's 821. It wasn't so bad. I told you you'd like this video, so like it. Ring that bell. Give me a little bit of love, kids. Mr. Visca, Visca's a teacher. I need love too. Follow me so you know when I put up the next few videos. Have a good day. Enjoy, and you got this.